Episode 4, folks. Mass resists acceleration. We are almost to Newton's law. If force causes acceleration, then mass actually resists acceleration. The same force applied to twice the mass will produce half the acceleration. 3 times the mass, 1/3 the acceleration. So we say that acceleration is inversely proportional to mass. If force is directly proportional to acceleration, then acceleration is inversely proportional to mass. The way we represent inversely proportional symbolically is by using this expression right here. Here we have proportional, and then inversely proportional, you put 1 over mass. That means that acceleration is inversely proportional to mass. Inversely proportional. Let's talk a little bit about proportionality. It seems more complicated than it actually is. When I say something is directly proportional, all I mean is that if you increase the force by 3 times, you increase the acceleration by 3 times. Force is directly proportional to acceleration. Increase the force, you increase the acceleration by the same amount. 4 times the force would be 4 times the acceleration, etc. Now, indirect proportionality just means that if you increase the mass, you actually decrease the acceleration. And in fact, it goes like this. Increase the mass by 3 times, and the acceleration drops down to 1/3 of what it was. If you were to increase the mass by 4, then the acceleration would drop down to 1/4 of what it was. That's indirect proportionality. There's still a relationship between mass and acceleration. It's just that when you increase the one, you're decreasing the other. Direct proportionality, you increase the one and you increase the other. One slight mistake. I should have said inverse proportionality, not indirect. It's inverse proportionality. So if acceleration is inversely proportional to mass, you increase the mass 3 times, the acceleration drops to 1/3 of what it was. That's inverse proportionality.